Hello Internet, today we're going to be working with something a little bit different. We're back in Unity and we are going to be making a line trace thing. Let me walk you through what I wanted to make, why it won't work, and then why I'm trying something else. So originally, you have this pillar here. This is sort of what I'm starting with, but we're going to get back to that. This particle system here is what I wanted to build. So you can see it's a physically enabled thing, so it's got collisions, and it actually will just draw this line and actually go underneath. That's important for what I want. But then it just keeps drawing these like randomly generated lines, squiggles, I guess. Sort of like random rock walls or something like that. I like the effect. I don't know. I thought it looked cool. The texture on these is just a triplanar shader that I wrote. The problem is, in order to do the effect that I want, I need to be able to draw these twice in the exact same position. So I would need to be able to redraw this particle system again. And I don't want to resimulate, I just want to draw it twice. I don't know how to do that. If you do, let me know, because that would make this way easier. But since I can't do that, we're going to discard this whole solution, even though it looks sweet. So that can just go away. And we're going to go back to this cube. So the way that particle system was working is there was a single tracer that was being shot out and just kind of weaved around. And then as it moved, it was emitting particles behind it, which looked like this. So they're just super tall with a pivot in the center, which means since that trail is trailing along the ground, they'd sort of spawn half in and half out of the ground. So I want to do the same thing, but I need to code it all myself. So that's what we're going to be doing. We're going to create our own projectile thing. It's relatively easy because we're actually, for this, I'm going to be working in 2D. So this is just a flat plane with a grass texture on it. There's no terrain or anything. So we don't need to worry about it going up or down or anything like that. If you want to do that, you can add it. It's not too difficult. You just need to do either a ray trace or find out some other way to keep it on the ground. A rigid body would work, but we're not really, I'm not super concerned about that just because I don't want to deal with it. So we're not. So let's create a projectile trail generator. So there's two parts to this, right? There's the projectile that we're firing. That's going to be invisible. You're not going to see that. And that's going to, I think I want to extend that particle system we have and actually have it branch. So there will be some branching logic. So let's actually call this a branching projectile. I think that makes sense. And so the idea here is every so often I'm going to want it to branch, and I want it to have a public number of times it can branch. So max or branch count. I will set that equal to 0 by default. So the idea here is if the branch count is greater than 0, that means it can potentially branch, which doesn't actually mean anything for this. All that I'm thinking is we're going to create a new projectile, have it at a different angle, and then they'll just go at the same range. So that's sort of how I'm planning on getting that to work. For this, let's do a float and just give it a speed. So that's going to be how fast it moves. I'll set that to like 5 for now. And then we need a thing that is going to give it when it should branch. So I don't really know the best way to do this. I think the best way is sort of an accrual method. So public float distance traveled sense branch, which is a bit of a long name, but it'll work. And then I want a public float. Let's make this first one private because we are going to handle that behind the scenes. You don't set that. Public float branch after distance. Yeah. So after it travels a certain distance, it's going to branch. And then public float lifespan, sure. and we'll just give it our life. So in the update, we're going to increment the life plus equals the time delta. So that's just going to increment the time. And then our lifespan, if the life is greater than our lifespan, then I want to destroy the game object and just get rid of it. So the projectile goes away after it travels a specific distance. This won't get rid of all of those columns we're going to be spawning behind it. And that's going to be handled in a separate script, so we don't really need to worry about that right now. For now, we need our life equal to 0, and our distance since traveled since the branch equal to 0 as well. That's just in the start. So those always get set to 0 to begin with, and then they'll increment over time. I think we're going to pull this out into a new method, like this.
Sorry, I can't help with that, but I'm always learning.
Katana's going off again. That's fun. Let's call this our update lifespan. Sure. So our update lifespan is going to just handle this, updating the lifespan. Let's zoom in so you guys can see that a little bit better. And now we need to actually handle traveling. So this should be really easy because all we're going to do is do this. Not that. Let's do our travel. What do we want to call this? Velocity? That makes sense. Velocity equals our speed times this dot transform dot forward, which is just the forward vector for whatever we spawn, and then times the time delta. So that's going to get us the distance we're going to travel in a specific amount of time. And so hopefully that allows us to actually move this thing. And then we need to increment this distance traveled since last branch plus equals our velocity's distance magnitude. And so that's actually going to update our distance traveled. And then if our branch should happen, we're going to do that. So if our branch count is greater than 0, and we need an and in there. If I could find it, what the heck? There we go. If our distance traveled since last branch is greater than our branch after distance. So we've traveled longer than we want to branch. The problem with this is it's going to be very static. We're always going to branch after the same amount of distance. We can change this by just throwing in some random values or some chance or whatever. For now, it doesn't really matter. It'll just kind of look like a tree. But that should be all right. So here's our branch. If the branch count is greater, then we'll do that. We'll take our branch count and minus equal 1. Our distance traveled since branch equals 0. And we're going to create a copy of what we have right now, which means I need a new one of these. I don't actually know a good way to copy things, so I'm going to guess, and then if it doesn't work, then it didn't work. But I'm curious if this works. I'm like 50% certain this won't work, but I think this will work. So we're gonna give it the exact game object that we already have, and hope it works. And so this is either going to infinitely loop and create a whole bunch of issues, or it's going to work and be awesome. I'm hoping it's the second one, because if it's the first one, then I have to restart Unity, and I don't really want to do that. So yeah, that's a good reason. So what this is going to do is create a new game object based on the current one at the same position and rotation, but the branch count got decreased. So it's a little bit lower. And then we can either modify one or the other. It doesn't really matter which branch we change. So I think we can actually just modify the current one. It won't matter because they're actually, the copy should have all the same values, which means its branch count will also be decreased. And so it should, like if we set this to 3, it will branch once, and then it will have 2 objects with a branch count of 2. and then those will branch, and then we'll have 4 with a branch count of 1, and then those will branch, and we'll have 8 with a branch count of 0, and those will just die off. At least that's what I'm hoping happens, because otherwise we're in trouble. So, do I need to? Yeah, let's plus equals this transform dot right. So what this is going to do, this is just for testing, just to see that this works. It's going to duplicate the object and move it to the right. So every time we branch, we should get another object to the right of it. I think that makes sense. By doing it this way, we'll get 2, and then we'll get 3, and so forth. And so hopefully we'll be able to actually visually see them, and I won't just need to use the inspector, because I don't really want to do that. And so that should handle branching. We're decrementing our branch count, our distance traveled. This is going to handle destroying it. The only thing we're not doing is moving. So this .transform.position plus equals our velocity. And there we go. That should be everything. I'm measuring velocity in total in meters, not meters per second, but actually in meters, which is a little, or in units, I guess, but it's a little bit of a weird measurement for velocity. So that might be a bit confusing, but I think it makes sense besides that choice. So just to test this out, I think the plan is to put it on this cube. So if we put it here, set the branch count equal to like 2, and we'll branch after 5 meters and give it a lifespan of like 5. So we should get 2 branches that happen relatively quickly. One should happen after the first second, and one should happen after the second, and then no others should happen. So let's pause this, start playing, go to our scene, which we have there, and then unpause this. There we go. There's 4. And no more. Oh, and the other ones live longer because it reset their time to live, because since they started or spawned again, their start parameter got called again. Because we put our start resets the life and the distance traveled since branch. Because that's there, what actually happened is life got set back to 0 even though the branch had just happened. So that was an interesting thing. So now, instead of this, transforming it to the right, let's do this transform.rotate. And we're going to rotate it around our up axis, because again, we're going on the XZ plane. So if I do up, that's going to be on the Y axis. So we'll rotate around that. So transform on our up. Sure. And then we need some amount of angle to change it by. I don't know a good angle, so I want to use random stuff because I think that makes sense. But I don't know a good range. So for now, I'm just going to guess. Random range from -1 to 1. I believe these are in radians, which is why I'm doing -1 to 1. So they'll still be in the general forward-ish direction, just not super forward. So we should see something a little bit more interesting now. We should see it go forward, then branch off. Or not. It'll just all stack one on top of the other. That wasn't what I wanted at all. That is going to be not the right angle, isn't it? That's not radians, that's degrees. Pretty sure that's degrees. We're gonna find out. Oops. Yeah. There we go. So those are our branches. They're kind of spreading out. Now, the idea here is I don't want all of that there. I know we just put, we put all this there. I don't really want it to do that. I don't want that to be our cube. So instead, I'm going to recreate a projectile. And we'll call it branching projectile again. give it some number of branches. We'll call it 3. Speed of, say, 10. I think if it moves faster, it looks cooler, so we're gonna do that. Branch after distance. What's the best way to do that? Branch after distance. It will branch too soon. Let's do 15 with a lifespan of 5. So it takes 5 seconds for this to spread out. It'll travel 50 units, and the longest branch will travel 80, about, I think, if I'm doing my math right. And so this will be our, call it the fissure projectile. And that might give you an idea about what we're doing next, but not in this video. So now we have these cubes. I need a copy of this. So we're gonna just drop it here, because why not? So we just have this tall cube. Again, this is a triplanar texture, which is why it scales so nicely. If you don't do that, it's gonna stretch, and you'll have to mess with your material to make it work. Triplanar shaders kind of solve that. So what we need now is something that will spawn projectiles behind it. So I think the easiest way is just something that will track your position and the next position, and then draw lines between that and spawn things. Alternatively, we can do sort of the particle system approach, which might actually work better. Let's do that. Particle mesh emitter. So this is the second of 3 scripts that I want to write for this. This is going to be our particle mesh emitter. Wasn't really thinking this was how I was going to do this, but oh well. So the way this actually does go on the projectile, what am I doing? So that goes on our projectile, and the idea here is it's going to get a prefab and then a number of things to spawn. So public game object, I guess, prefab, and then a public int. Let's do a float. I think a float makes more sense here. This is going to be our spawns per second. Gonna have to think about the math for that because I have no idea what that function looks like. And then a private float accrued spawn count, which is going to be how many spawns you've accrued for the current thing. And we're also going to need a public float spawn radius, which is just there to give everything a little bit extra so that it's not all just spawning one on top of the other. If you would spawn like 5 things, they don't all spawn one on top of the other. There will be a little bit of jitter to them, so it doesn't look as uniform. And I think that's it. So the idea here is we increment the accrued spawn count by some amount, our time, delta time divided by our spawns per second. I think that makes sense. Does it? No, that doesn't make sense. Spawns per second divided by the time. That also doesn't make sense. Hold on, times the time. I was making that way more complicated than it needed to be, but now it works. So the idea here, spawns per second is how many times you want to spawn something per second, so let's multiply it by time, and then we'll accrue however many things we need to spawn. And then for I from 0 to I less than the accrued spawn count, we're just going to spawn things inside of that radius. And that's it. That should be everything, I'm pretty sure. And so this is just going to instantiate one other thing, sorry. If our accrued spawn count is greater than 1, if there's something we'd spawn, we want to do this and actually spawn the thing. But I don't want to do it if it's less than that. And so the reason for this is we could get into some issues here. I don't think I want it like this. This will work. It's just a little bit finicky. And so the part of the issue with doing it this way, we're counting from 0 to whatever. We're effectively going to spawn things over and over again whenever. So the way this is working is if it's greater than our crude spawn count, if it's greater than 1, which means we want to spawn one thing, then I'm going to do X iterations of it. And in that case, X is going to be equal to the accrued spawn count, which is actually going to be greater than 1. So I think we actually want that at 1. Actually, making this more difficult again. Let's just do a while loop. While accrued spawn count greater than 1. Simple. We don't even need this anymore. Making this way more complicated. So the accrued spawn count, while it's greater than 1, we're just going to spawn something. So we need a position to spawn it at. So vector 3 position, which is equal to our current transform. And then we need to jitter it on the X and the Z axis. We could either do a box or we could do like a circle. Either one works. Not sure which is best. So let's just grab our circle position equals to this, or not this, our random inside unit circle. That's going to get us a vector 2 that's inside a unit circle somewhere. So it will be a unit circle that is from 0 to 1, but it may not go all the way up to 1. So it'll be, if you draw a circle, somewhere in there. That's pretty much it. And so the idea here is we can actually multiply that circle position by what we've actually calculated up there. So the spawn radius, multiply that by the circle that we get, and we'll find somewhere within that spawn radius that's in a circle. Should be pretty straightforward. Then I just need to multiply that by our circle position dot x, and this is just modifying those two things. So we have our z, which is going to add the y. Just doesn't line up because they're in two different dimensions, but you get the idea. So circle position, this needed to be modified by the spawn radius. Multiplied, not modified, because they're the same thing, but oh well. So, circle position, positions. Now we just need to spawn the thing. So, let's do that. Let's instantiate a prefab at our new position with a new rotation. So let's do an Euler angle at 0, 0, 0. That's actually not what I want. I would like this to be a random range. Is random angle an option? Nope. Random range between 0 and 360. And so I don't want all of the pillars to all line up with one another. I'd like them to kind of be a little bit rotated. And so this is going to do that. It's just randomly going to rotate all of them. And I think that should get us what we want. Let's, oops, lost one of my screens. There we go. So if I start this now, I didn't set anything, so that's not going to do anything. Let's actually do this correctly. Put our cube on the prefab. Spawns per second. We're going to set this to 10 and a spawn radius of 0.025. And so if I run this now, we should get a whole bunch of cubes. I hope. Or I created an infinite loop because this while loop has no exit. Oops. Well, I'm going to need to restart Unity because I just totally killed it. Accrued spawn count minus equals 1. That's important. I probably should have done that first because now this is dead. Yeah, totally dead. So one sec, I'll be right back. Okay, so I think I'm back to where I left off. Yeah, I dropped my scene because it hadn't saved it. So now I think we're at the same spot, but it might be a little bit different. we have our branching projectile and our particle mesh emitter, and then we have this cube. And that's it. So, the general idea, oops, that's not right. I didn't do it again, did I? The heck? What's going on? Oh, I didn't save. Oops. I made the change, but Unity and Visual Studio don't play well together. So what happened is it opened it up in this weird thing, which I'm pretty sure just means it didn't find it in the solution, or Visual Studio is broken. I like to use that second one because that's true. And it didn't actually save, which means that this change didn't get in, and I have to restart Unity again. I'll be right back. Well, the good news, I saved the scene before that happened, so we can start right back with the same thing. And I can actually, now that it's saved, I can click this, and we get all of these fun pillars. And it looks like a tree. Yay! So all of that's working, doing exactly what I had hoped. And that actually looks sweet. Why are you stretched? My triplanar shader, I wrote that in a very quick amount of time, so it might not be perfect. Clearly I've screwed something up because that is not right. But we're definitely getting a similar effect to the particles we had before. Oh, and our particles are actually active already. So we're definitely getting a similar effect. The particles are denser and they're smaller, so it's hard to compare, but it's similar, which should be good enough for what we need. I think we can move on. So the real thing that those particles have that our current thing doesn't have is there's an animation on the size, on the scale of how these shapes look. So that's what we're going to be building next, which should be the final thing. So we need those walls to despawn, and we need them to have a curve over their lifetime for the scale of them. So I think I have a solution to that. We're going to use animation curves. So scaling, destroying fragments. That's a word. Sure. And so the way an animation curve works is you get some set amount of time, it can be anything you want, and it will animate over that time, it will animate a specific float, which works great for us because we can just multiply our scale by that, and we're done. So, animation curve. I'm getting concerned because there's no IntelliSense. I'm pretty sure, so I switched back to Visual Studio 2015, because Visual Studio 2017 was completely broken. Clearly, Visual Studio 2015 is also broken, but this one doesn't get into a crash loop, so I think that's a bonus. Not great, because IntelliSense is gone, but whatever. So we'll just write and then hope it all comes together in the end. I don't know what else to do. Private. We're going to save our initial scale and just multiply it by the result of that curve. So this is going to be our initial scale. Sure. And we need a life as well. Public float lifespan. So ideally I'd probably like to, we've done lifespan twice now. I'd like to break that out, so that they're not both just implementing the same thing. That seems like a waste. So I'm just gonna grab that, and we'll use it for now. But I think in the future, I'll probably have pulled that out because it doesn't make sense to maintain it like this. We're not getting any benefit from having two separate implementations of it. It just makes our life harder. So update lifespan. We've got our life, which we don't even talk about. Let's do a private float, and we'll call it life. There we go. And everything should be operating very similar to how it was previously. We just need to save our initial scale. This transform.local scale. I'm kind of guessing at these names because Visual Studio is broken. But, oh well, it happens. So our initial scale is equal to that. We've got our updated lifespan. All of that should be good. Now I need to plug this into our animation curve. So, curve, gonna have to guess at this. So this transform.local scale equals our initial scale times our, let's see, we're going to multiply it by the curve evaluate. I'm pretty sure that's what it is. And then the idea here is lifespan, or life over the lifespan. Lifespan. I really don't like it trying to fix this for me when it is already broken. Just stay broken. Alright, initial scale times the evaluated curve. And that should get us our result. So the idea here is the evaluate needs to be between 0 and 1. So this, since our life can't go greater than our lifespan without killing the object, this should work. It'll start at 0 and then count up, and we should be able to just use that for our scale. Hopefully. No errors? Maybe? Cool, no errors. I think. Confidence is very good right now. Oh, also this is super cool with triplanar shaders. You can move them and the textures stay in place. That's cool. Then let's do we have them under projectile. The scaling destroying fragments, because of course I named them that. Why wouldn't I? Let's give it a lifespan of 15. I think that's what I had for the initial particle system, so it should work for us. Set this for our value and time equal to 0. And we'll go back to 0 at a time of 1. With animation curves, actually, you can go greater than 1. You can actually scale this out as much as you want. It just, I don't know. I always go between 0 and 1 for when I'm doing stuff like this. But that's just me. So you don't have to do that. That looks like a fair enough curve. You get the idea. It kind of ramps up quickly, and then we'll kind of stay large for a while, and then we'll slowly kind of deteriorate over time. I think I approve of that effect. We'll find out. So I should be able to run this now. And we get that. You'll notice they're flashing in because they spawn at that specific size, and they're all at the same height. It looks very linear. Like that's just a line. That's just a line. So we probably want to vary the height as well, because that doesn't look good. But other than that, I think we're pretty close. They're very spread out, and I don't really like that. But we can just increase the spawn density, and we should be good. So let's do that. Spawns per second. Change that to 25. Spawn radius, we'll increase that a little bit to, say, 0.4. Save all of that. So hopefully they're a little bit more spread out, they're a little bit more chaotic, and there's a lot more of them. Next, let's actually change the branch. I'm going to branch a little bit less, because I just think that'll look better. And then, let's see. Let's actually just see what this looks like. And then we should be just fix this, so they're not spawning in right there. That's interesting. They barely branched at all. Did I change something else? Maybe. Nope. Okay. That was just random chance. Cool. So now we just need to change the height, because the height is throwing me off. So let's do position.y plus equals our random range from 0 or -1 to 1, and multiply it by our offset height max. That doesn't exist, so let's actually create that. Public float offset height max, and that's just going to kind of offset the height by some value, and that way it'll kind of go up and down depending on what we set. We don't need this to be very big, but 0.2. My num keys are very sticky, so that's what happened there, but no, they still aren't very random. They're more random, but not as random as I'd like. We can change one more thing, which is in here. Instead of this lifespan, let's make that private. And let's do a public min lifespan and a public float max lifespan. So this will give us a range. We can just use another random function. We're using a lot of those. It's probably not for the best, but we'll try it anyway. I don't really care too much about performance right now. I just kind of want to get the effect, and then we can figure out how to do that. We'll probably have a lot better ways to do this, but this is just for mostly testing at this point. So let's start this and see what happens. Errors. Lots and lots of errors. Local scale is not a number because I didn't set the value. Oops. That's not good. Let's add this back. Our min and max lifespan were 0, which means everything was 0, which means our scale was 0 or divided by 0, which isn't a good thing. Let's not do that. Let's do between, this doesn't actually need to be super big. It will just create those offsets. So the curve will evaluate at different rates. That's sort of what I'm going for. So 14 and 17, I just modified those while it was playing. Let's go 13 to 17. That gives us like 4 seconds of leeway between two almost adjacent things. That's probably too much. 15 and 16. That's should be good. I don't want it to be too dramatic because I want it to look fairly like you're casting a spell, like a wall in the ground. And then I want it to kind of disappear afterwards. So hopefully we kind of get that effect. Not really. Still very linear. And I think part of the problem is our curve is wrong. So I think we can fix that with this. Just drag it out here more. And that way it just drops off a little bit faster. Sort of like this. Yeah, there we go. That's a little bit better. Not great, we're just kind of guessing, but I think that'll be a little bit closer. I didn't apply that. Let's do that. Disable this so it doesn't get in the way, and then run this again. Hopefully this one turns out the way we're kind of expecting it. They all grow at a very similar rate. Maybe we should randomize the size, because I feel like that's just not, it's just not working. Like they get random here, but nobody cares at that point. I don't know what I'm doing here. I'm just kind of playing with values. That's how I do effects. So, we'll figure it out. That should be done by at this point. I'm not going to fiddle with it too much. For the scalings thing, we can randomize the scale if we want to. Let's public float scale diff. I don't know if that's what I want to call it. But it should work. another random, because at this point, let's abuse it. 1 minus the scale diff to 1 plus the scale diff. And so what this is doing is just you give it a difference, and then it will do between 1 and that. So it'll be 2 times the difference that it can find something. And that way the scales won't be exactly the same. Hopefully that gives us some randomization. Or not. I don't know what a good value is, so we're going to go with 0.1. Apply that. Save. And hide our cube. And now we should get this very nice thing. There we go. That looks a little bit better. It's a little bit more offset. They grow pretty slowly, but I think that's all right. And then that happens. So now they're all growing or shrinking. I don't know. I'm pretty happy with that. It does sort of what I wanted. And it gives us the ability to do those branches and things like that, which make for a pretty interesting effect. So I think we'll leave this here. It gets us to the point of being able to do what I had intended in the first place. And it's relatively close to this particle system. It's not the exact same, but you kind of get the idea. And it's definitely not going to be as efficient, but again, we can play with that. So that's what the original looked like, and that was our effect. So I don't know, this one feels more responsive. It feels more reactive. And the transition is very abrupt, which is sort of, I spent more time on this one, but I think you get the idea. So yeah, I'll leave it here, and then we'll pick this up. I'm planning on finishing this quick, probably this week. So yeah, I'll see you guys in the next one. Till then, see you, internet.